So, welcome back, learners, to the second part of our Langet Kcse revision. This question here, if you're watching our channel for the first time, first and foremost, subscribe to our channel, you like and you share. If you look at this question here, you're told, give an equation for the reaction between the elements we have given in E, that is element L and element T. So if you look at element L up here, element L is in group 1. That means for element L to be stable, it loses 1 electron. And element T is in group 7. That means for element T to be stable, it gains 1 electron. So in any case, they are all valency 1. The only difference is that T is diatomic, but L is a metal. Okay? So this L is a metal, and this T is also a diatomic gas. But remember, they are all valency 1. And that's why you can see that I've written here that this T, remember this T, it has to be T2. This has to be T. Remember, this is L, which is a solid. So I'm adding it to T. And where this T, because it is diatomic, it has to be 2. So I'm going to indicate here this T is 2. This T is 2. This T is 2. Just 2 there. And this T is a gas, because remember, members of group 7 are called halogens, and most of them are gases. So if I react L with T2, I'm going to get LT. And you may be wondering, why is it that here is 2? Napa ni LT. Remember, I said they are all valency 1. This one, L loses 1 electron to become stable, T gains 1 electron to become stable. But T exists as a diatomic gas in nature. So for you to balance this equation, you have to ensure that this equation is balanced, because when you look at this side, L is 1, this side, L is 1. This side, T is 2, this side, T is 1. So you must ensure that here, umeandika nini? Umeandika 2. You must ensure that there you balance with 2. And then you balance there with 2, you are going to, this should be L, there's an L there, should be 2LT gas. Now when I write there 2, remember L is also becoming 2. So huku pia nitakuja kuweka 2. So that is going to be the equation for that particular what? That particular reaction. So I'm also highlighting it so that you can note it very well. Okay? So that is the equation for a reaction for that particular equation. And this one, you can adjust it. Ukiona inashikana sana unaiadjust ikuje mbele. So the next question you asked, which element has the smallest atomic radius? For you to determine the element which has the smallest atomic radius, you look at the element with the smallest number of protons. The smallest number of protons. That is most likely K, because it is the one having the smallest number of protons. It is the one with the smallest number of protons. So it automatically becomes the element with the smallest atomic radius. So your answer there will be element K. And your reason is it has the smallest number of protons. Remember, the protons are the ones that increases the nuclear force of attraction. So the lower the number of protons, the smallest the atom. The lower the number of protons, actually this question is asking which element has the smallest atomic radius. The smallest atomic radius goes with an increase in number of protons. That will be element S, not element. That should not be element K. That is element S. And there's a reason. Element S becomes the one with the smallest atomic radius because it has the highest number of protons, not smallest. This should be highest. Highest number of protons. The highest. The highest number of protons. That means the more the number of protons, the increase in nuclear force of attraction, and that is what causes a decrease in the atomic radius. Okay, so that is important. That can be well noted. Now when you go to the next question, you are asked, Give the number of valence electrons in K and T. So you look at K. Ukitaka kujua K, siko group 2. So inamaanisha the valence electron are 2. T iko group 7. You know group 7 members, how many electrons do they have in the outermost energy level? They have 7 electrons in the outermost energy level. So this K has how many valence electrons? This K has 2 and this T has 7. Okay, so this you can also highlight. I'm going to highlight it so that you can see it well. So K has 2, T has 7. Okay, that is important. So we go to this question. You're told to study the scheme below and answer the questions that follows. So these are flowchart questions. So if you're provided the flowchart question, you must study it very well. So here you have oxygen. It is coming from hydrogen peroxide. This oxygen is reacting with something here and then you form sulfur 4 oxide. This oxygen reacts with copper and then you form substance U. This sodium peroxide here is also forming oxygen, and this sodium peroxide is from sodium, and this sodium peroxide you react it with water and then you form solution V. So you must understand all these processes and how they are taking place. Let me start with the first question you are asked. Identify substance U and V. Let me start with substance U before I come to substance V. In substance U, you're having copper reacting with oxygen. When copper reacts with oxygen, you form copper 2 oxide. So that means substance U is copper. Substance U is copper 2 oxide. And if you look at substance T, substance V is where now sodium peroxide is reacting with water. You know, when sodium peroxide reacts with water, this is used to form oxygen gas. When sodium peroxide reacts with water, you form a solution which is called sodium hydroxide and oxygen gas. So this solution that you're forming here, which is called solution V, this is sodium hydroxide solution. So just come and note here, the solution V is sodium hydroxide solution. Sodium hydroxide solution. That is solution V. Now, this is important, let me note this. And remember, because you've been told to identify. So you can even write the chemical symbol because the question is very open. Umeambiwa to identify. So hata hii, let me return this. Even this copper 2 oxide, you can write its chemical formula. Unaweza andika tu copper 2 oxide. CuO. And then sodium hydroxide, you can also just write it kwenye iko. Sodium hydroxide. Okay, so that is important. Now this next question you are asked, name the reagents necessary for the reaction taking place in the following steps. Step 1, look at step 1. You are asked, this is hydrogen peroxide. Which reagent do you need to convert hydrogen peroxide to oxygen gas? Of course, you need a catalyst here. You can remember from your Form 1 knowledge. The catalyst that you need here is manganese oxide, because hydrogen peroxide reacts in presence of manganese oxide and then you form oxygen gas and water. So the reagent that you need in step 1, because you've been told to name, so you must give the name. So you'll just write manganese oxide. Manganese oxide. Now you look at step 2. For step 2, look at, you're having oxygen and then you are reacting with something and then you're forming sulfur 4 oxide. So that means most likely substance umeongeza hapa ni sulfur. So the reagent that you need in step 2 is what? Is sulfur. Okay. For step 3, look at step 3. For step 3, what are you adding in step 3? You have sodium peroxide and then you're forming oxygen gas. What do you add to sodium peroxide for you to form oxygen gas? The substance that you add to sodium peroxide to form oxygen gas is water. So whatever you need in step 3 is what? Water. So you can also highlight this so that you note it. Highlighting it in a different color so that you can see very well. So you can see that in step 1 what you need is manganese 4 oxide. In step 2 what you need is sulfur, so that sulfur reacts with oxygen to form sulfur 4 oxide. And in step 3 here what you need is water, because when water reacts with sodium peroxide you form sodium hydroxide and oxygen gas. So I think up to there, learners, you've also learned something. I'm doing another successive video on this particular paper so that you learn more of these concepts. If you're watching our channel for the first time, take time, subscribe, like, and share.